Okay, we learn characteristics of DC series motor. First one is speed current characteristics. We know three characteristics are there. One is speed current characteristics, that is speed versus armature current characteristics of the motor. And second one is torque versus armature current characteristics. And third one is torque speed torque characteristics. So three characteristics that we need to study for series motor, particularly series motor that we will study today. If saturation and armature reaction are neglected, then main flux in case of series motor is directly proportional to the armature current IA. Therefore, we may write that phi is equal to C into IA. That is some constant into IA, or C is a constant. Now, we know that EA, that is armature EMF. Armature EMF is equal to Ka phi omega m. Ka is armature constant. Phi is the flux. Yeah, this flux is due to series field. Omega m is the rotation, that is angular speed in radian per second of the machine. Now EA is also given by Vt minus Ia into Ra plus Rs from the voltage equation. So from this equation we can write that omega m, that is rotation, that is speed of the motor, is given by omega m is equal to this equation by divided by Ka. So Vt by Ka minus Ia into Ra plus Rs by Ka. So we are getting two terms here. Now omega m, in this equation, if we replace phi with Cia, then Vt by K Cia, Ia will be replaced with Cia here. Here again phi will be replaced with Cia. So Cia, both Ia in numerator and denominator will cancel out. Yes. It will give Ra plus Rs by K into C. So we are getting this equation. So it is seen that with saturation and armature reaction neglected, the characteristics of series motor, the speed torque characteristics of series motor is the equation of high parabola. It's the equation of high parabola. If we consider the effect of saturation and armature reaction, for increased value of Ia, the flux phi will increase, but due to demagnetizing effect of armature reaction and saturation, the air gap flux tends to remain approximately constant, not constant, approximately constant. So omega m in this case can be written as Vt by K phi minus Ia by Ra plus Rs by Ka phi, as it is approximately constant. Hence the first term of the equation is a constant. This term is a constant because phi is constant, K is constant, Vt terminal voltage is also a constant. And this one, second term, Ia is increasing. So this is increasing Ia into Ra plus Rs. This is increasing. So the torque, so the omega m will decrease linearly. This is equation of linear equation. Now the speed current characteristics of a series motor for larger value of Ia approaches a straight line. So equation characteristics will approach a straight line. This is the this is the equation graph between speed and armature current when saturation and armature reaction are neglected. That is the equation of high parabola. Now, if we consider saturation and armature reaction, then it will follow this curve. The curve will bend here because it is now becoming the equation of straight line. Speed current characteristics. Speed current characteristics at no load, the armature current is very small. Because of this, power input to the motor has to overcome the no load losses only. Thus, the voltage drop Ia into Ra plus Rs is not at no load is almost negligible as compared to Vt, and hence no load speed omega m0 will be given by omega m0 is equal to Vt by Ka by K into phi is equal to Vt by Ka into Cia. Phi will be replaced with Cia. Since omega is inversely proportional to I0, that is no load current. Omega is inversely proportional to Ia. Here it will be Ia or I0. No load speed. So no load speed of the series motor becomes dangerously high due to small no load current. From this equation, we can say that omega m0, that is no load speed, is inversely proportional to current. Speed is inversely proportional to current. So at no load, current Ia will become I0, and it is very small in practice. Hence, omega m0 will become very high, dangerously high. So series motor will never start with no load. Always will be started with some load. Torque current characteristics. With saturation and armature reaction neglected, we know phi is equal to Cia. That is the equation of flux with armature current Ia in case of such a series machine. So equation of T is given by A into phi into Ia. Hence, T, if we replace phi here, T will become K C Ia square, that is some constant C1. Here C1 is the multiplication of A and C I square. The torque is proportional to square of the current, square of I square. Therefore, torque current characteristics is a parabola. So here we are getting a parabolic nature. But for larger value of Ia, the net flux tends to remain approximately constant. Consequently, the torque current characteristics approaches a straight line. This flux is, as for larger value of current, flux tends to remain approximately constant. So the equation is becoming, for larger value of current, the equation is becoming a equation of straight line. This is a torque equation. For lower value of current, the torque is following a parabolic nature, and for higher values of current, it is becoming almost straight line. Torque characteristics. If saturation and armature reaction are neglected, we know T is equal to K A C I square, or Ia is equal to root over of T by K C. From this equation, we can derive the equation of Ia. Now, equation of speed is given by omega m is equal to Vt by K C Ia minus Rf R S by K C, that we already derived. Now, put the value of Ia in this equation. It will give this equation that is related to speed and torque. Now, with negligible saturation and armature reaction, the speed characteristics is a high parabola. So, it's the equation of high parabola. It is given by the solid line, and if we consider armature reaction, then it will shift upwards. With saturation and armature reaction, when the saturation and armature reactions are included, large torque requires large current, and thus large current tend to make the air gap flux constant. Thus, TE approximately equal to A into Ia, and the equation of the speed becomes this. That is, omega m is equal to Vt by K minus T into Ra plus Rs by Ka square phi. When the current is large, and torque is given by Kia. Thus, above a certain value of torque, with air gap flux remains approximately constant, speed torque characteristics approaches a straight line as shown in the previous curve. It is, yes, this is the uh, curve of speed torque when saturation and armature reaction are included. It is seen that the speed drops at increased it is seen that the speed drop at increased load torques is almost negligible. The speed drop is almost negligible.